before we get started properly with this video, I've got a lot of classes now, all with the name dog, and they're starting to collide with each other. And this is a bit annoying when we want to make modifications to the dog class. So what I've done is I've added a new folder inside of the current video called inheritance, and at the top of inheritance.java I've got package inheritance, and I won't go into too much detail about what packages do at the moment. They just separate the code, so this dog class will no longer conflict with any other dog classes. Okay, so let's say we have two quite similar classes. Here we've got a dog class and we've got a cat class. And down here in the main function, we've got an array of dogs called pets. Okay, so we've got two kind of potential issues here. So the first one is that because dog and cat are very similar, we've actually got a lot of repeated code. We've got a string name, int age, and the whole birthday method are all the exact same in both of these classes. Now that's not an inherent issue, but it's something we want to try and avoid. There's a principle known as the dry principle, the don't repeat yourself dry principle. And we want to keep to that as much as possible, so we don't really want to have repeated code. The other issue is down here in this array of dogs, we've got the variable name pets, and so semantically we might think, okay, we could have some dogs and some cats. Now, if that's actually what we want, how do we represent that? How do we mix objects that are dogs with objects that are cats? Because if I was to come in here and say new cat with the name cat and an age of 7, then you can see that this isn't allowed. We cannot convert a cat to a dog, and we don't really even want to be converting the cat to a dog. We just want to be able to store one of both. And so that presents a bit of a problem. How do we mix these two two classes? So we can store these two values in the same array, and that's because they have the same data type. But let's think about what we're trying to represent here. We've got a dog called Benji who's 5 years old, and we've got another dog called Bailey who is 10 years old. What do these two objects have in common? Well, they're both dogs, and that's why we have the class dog. But if we want to mix types to have a dog and a cat, we need to find something that unifies all three of them. We need to find something that is common between every single dog and every single cat. And there are a lot of different options here, but every single dog and every single cat is an animal, so we could go with that. So now that we've got something that unifies all of these together, we can come up to the top and we can create an animal class. So let's do that. We've got class animal. Okay, and let's copy over all of the properties and methods that were duplicated, that were present in both of these classes. So we've got name, age, and birthday. Let's remove some of this space here, and let's take them out of this class. Okay, let's also create a constructor for animal because we've got name and age. So let's do public animal. We want to take in a string, and in fact let's copy this and paste it in there, and copy this and paste it in there. Okay, so we've got an animal class now. So what we want to do is we want to essentially copy all of these, the string name, the int age, and the method birthday. We want to copy those down to both of the classes. A dog is a type of animal. It's more, if I say something is a dog, that's more specific than saying it's an animal. But if I say something is a dog, you could also tell me that it is also an animal. So the way that we can represent that is by using inheritance. So if we have class dog extends animal, and what this means is that an object of the dog class will have any new properties that we specify. So maybe we have breed like before, but it also has the properties of animal. But VS Code has given us an issue here. We've got implicit super constructor animal is undefined. So basically what we need to do here is inside of our dog constructor, we need to call the animal constructor. We need to construct an animal in order to construct a dog. And so we can take this out and we just need to do super, because animal now is what's called a superclass. There are a few different names for it. It's also a parent class. Dog, when we do class dog, it extends animal. Animal is the parent class or the superclass, and dog is the child class or subclass. And there are probably some other names as well. But when we do super like this, we are calling the animal constructor. So we just need to add in new name and new age, which are the parameters here. Let's do the same for cat. So we need to do super, new name, new age, and stems animal. Okay, so the only thing we have left to do now is to change the type of this array to animal. So now we've got an array of animals, but we've inserted some values that aren't directly animals, they're dogs. But because we've got class dog extends animal, we know that all dog objects are also going to be animals. And because of that, we are allowed to put dogs into a variable or an array that stores an animal. And then the one last thing we need to do is change this to animal. And if we run the program now, we can see that we get Benji, Bailey, and cat. The first object in the pets array is Benji, which is a dog. We can access this this dog by doing pets at index 0. And the dog class has a method called woof that prints out the name of the dog and woof. So what if we want to make Benji bark? We should be able to do pets at 0 to access this item, and then dot woof. But you see we can't do that. The method woof is undefined for the type animal. The animal class doesn't have the method woof. Dog does, but because we've got this dog inside of an animal array or an animal variable, we're not able to access this method. We can only access the properties and methods from the animal class. So what if we want to do something that is specifically added to a subclass, to a parent class, to a child class? What if we want to do, we print out the name, and then if it's a dog, then make it bark. There are a few different ways we can do this. The first one is we can say if pet, and we use the keyword instance of, and dog. Okay, so if the pet, so if the individual object that we're looking through one by one, if this is an instance of the dog class, we know that it's an instance of an animal class, but we don't know for sure, such as in this case, that it is an instance of the dog class. But we can use this check here, if pet is an instance of the dog class, and now we know that the pet is a dog. So what if we do pet.with now? Well, this doesn't quite work either because pet is still an animal type. Some languages might let you do this directly because you've got this check. But what we're going to need to do is we're going to need to create a new dog object. And we're not creating a new dog object like we've got here, but we're just converting the animal object into a dog. Okay, so we can do dog equals, and we want to convert something into a dog, and that's going to be the pet. Okay, so we're going to convert the pet, only if it's an instance of dog, into a dog. And now we've got that stored to a variable, and we can do dog.with. And that's allowed because dog is now of type dog. So if we run this, we can see we get Benji, Benji, woof, Bailey, Bailey, woof, and then just cat. Because cat is not a dog, we don't enter this if statement. If we were to miss out this if check, if we were to just try to convert any of the objects to a dog, let's see what happens. We get Benji, Benji woof, Bailey, Bailey woof, cat, and then we're getting a runtime error. We're trying to convert this object into an object of the type dog. And we can't do that because it doesn't match up, because we've got a cat, not a dog. And so we're getting a runtime error. That's why we need to do this if check. We could also check if the pet instance of cat can do something different. We can do cat equals cat pet, and then do cat.meow. And we get all of the kind of voices of the objects. So this kind of works, but we've got quite a lot of lines here. We've got two different types of object being stored as pets, but what if we had other animals as well? So maybe, I don't know, parrots, hamsters, whatever other kind of pets you have. For every type of pet that we have, every other type of animal that we want to store in this array, we would need another one of these. We wouldn't necessarily need it. For example, if we were to take this out, it runs just fine. It's just that the behavior that's unique to the cat would be ignored. So if we do want unique behavior for each of these objects that are being stored all together, we're going to have a lot of code, and that's not ideal. But if we have another look at the output, we can see that the outputs are quite similar. They're of the same structure. We've got the name, and we've got the sound that the animal makes. And so, even though we're doing something different, it's the same idea. So what if we were to go to the animal class and add a new method, public void, and let's call it speak. And in this method, we're going to have system.out.println. We're going to have the name, and then just animal sound, maybe like that. Okay, so what we can then do is we can go into the subclasses, into dog, for example, and instead of calling this method woof, we are now going to call it speak. And I'm also going to add here @override. Now this isn't strictly necessary, but what we're saying here is we want to change this method that we've defined in the animal class. So if inheritance is where we copy all of the methods and properties from one class down to a subclass, polymorphism is where the subclass then changes it or tweaks it slightly to make it more specific, to make it do something that this particular object would want to do. So if we do the same kind of thing for the cat, when we do speak, let's add @override, and I don't think we need to change anything else. We now don't have access to these methods because they have been deleted, but if we take out all of this, we should just be able to do pet dot and what was it called, speak. Let's run this. We're getting the same output as before. And this is quite strange because pet is of type animal. So if we go to the animal class and we look at the definition of the method speak, we've got the actual words animal sound. But when we actually use it, because we've constructed dogs and cats instead of animals, we could just add another one here. New animal test. Need to add a comma there, and if we run this, then you can see we do get animal sound. But if we've created a dog or a cat, we will have the overridden effects instead of the default effects. And that's all there really is to inheritance and polymorphism. You can have more classes involved. You don't have to have just a parent and a child or a superclass and a subclass. You can have one class and then the next class inherits from it, and then the next class inherits from it, and the next class inherits from it. I would advise against that because it gets quite difficult to follow, but it is an option, and polymorphism works in those as well. You also have an idea called composition, which is instead of copying everything down that you need, an individual class can specify what functionality it needs from a different class. But we're going to have a look at that in a later video. But that's all for now, and the next video will be about interfaces and abstract classes.